Good morning, students. In previous lecture, we have seen the concave lens and how a image is formed when an object is placed in front of the concave lens. Now, in today's lecture, we will discuss about the lens equation. The lens equation The lens equation is an equation that relates the object distance, image distance, and the focal length. The object distance P is the distance between the object and the center of the lens. It is taken to be positive if the object is real, and it is taken to be negative if the object is virtual. The image distance Q is the distance between the image and the center of the lens. It is taken to be positive if the image is real, and it is taken to be negative if the image is virtual. The focal length F is the distance between the focal point and the center of the lens. The focal length is taken to be positive if the focus is real, and is taken to be negative if the focus is virtual. This means the focal length of the convex lens is positive because its focus is real, and that of the concave lens is negative because its focus is virtual. The following equation is the so-called lens equation, and it is given by the formula 1 upon F equals to 1 upon P plus 1 upon Q. Here in this equation, 1 upon F is the focal length, 1 upon P is the distance of object, and 1 upon Q is the distance of the image from the center of the lens. The magnification of a lens is defined to be the ratio between the size of the image Hi and the size of the object, that is Ho. The size of the object, that is image, is taken to be positive if the object image is erect, and it is taken to be negative if the object image is inverted. The magnification is given by M equals to Hi upon Ho. The magnification is also equals to the negative of the ratio between the image distance and object distance. Therefore, M is given by minus Q upon P, where Q is the distance of image and P is the distance of object. Now, with using this formula, we will solve one example. That example is of this type. An object of the height 0.03 meter is placed 0.3 meter in front of the concave lens, whose focal length is 0.06 meter. Calculate the distance of the image from the center of the lens. For calculating the distance of the image, we use the formula 1 upon F equals to 1 upon P plus 1 upon Q. Here in this example, the given things are the focal length is given and it is 0.06 meter. The distance of object is also given and it is equals to 0.03 meter, and we have to calculate the value of Q, that is the distance of image. Here in this equation, the value of focal length is taken negative because the focal length is negative because the lens is concave. Putting these values in the equation and rearranging the lens formula for Q, that is of this type, 1 upon Q equals to 1 upon F minus 1 upon P, that is equals to 1 upon minus 0.06 minus 1 upon 0.3. And solving this equation, we are getting 1 upon Q equals to 1 upon 20 meter. Now, calculating this value for Q, that is the distance of image, it gives us 1 upon minus 20 m, and therefore last answer is q equals to minus 0.05 meter. Means here using this formula we have calculated the value of q, that is the distance of image, and it comes to be q equals to minus 0.05 meter. Now the next question is the image real or virtual? It is a virtual image because the image distance is negative. The third question is calculate the magnification. The formula for magnification is given by in the form of the negative ratio of image distance upon the object distance, that is equals to m equals to minus q upon p, and that is equals to minus of minus 0.05 divided by 0.3, and we solve this mathematically, then we'll get m equals to 0.17. This is the magnification ratio. Now the next question is calculate the height of the image and determine if the image is erect or inverted. Solution: h equals to 0.03 and m 0.03 meter, and we have to calculate here the value of h. Therefore, m equals to hi upon ho, where hi is the height of image and ho is the height of object. Therefore, h equals to m by h, it is equals to 0.17 and 0.03. If we calculate this, we will get 0.051 meter. The image is erect because the value of h is positive, and in this way we have using this formula of length equation, we have calculated the value of f, value of p, value of q, and the magnification ratio. I think this much is the enough for this point. Now the next point we will see in the next period. Today we will stop here.